It's the most familiar force in our lives, right? The one that literally holds us to the earth. And for centuries, it was also the most mysterious. Then, one man, with nothing but the power of his own imagination, he tamed it. With pure thought, he cracked one of the deepest riddles of the universe and completely upended our understanding of reality itself. This is the story of how he did it.
But here's the thing. To get his genius, you can't just picture the old man with the crazy hair. You have to see the man himself. A man under unbelievable pressure, working in Berlin while World War I was tearing Europe apart. His personal life was a mess, and he was in a dead sprint against a brilliant rival to finish a theory that would change, well, everything. This wasn't some quiet academic project. No, this was an act of intense, almost desperate creation.
So, where does a mind like that even come from? How do you learn to think in a way that no one else has? Well, it wasn't born in a university. The seeds were planted way, way earlier, with the simple curiosities of a child who just saw the world differently.
When he was just a little boy, his dad showed him a simple compass. Now, most of us would think, neat trick, and just move on. But Einstein, he saw a deep, profound mystery. He saw that something invisible, some hidden field, was reaching through empty space and forcing that needle to point north. And that single moment sparked a lifelong obsession to understand the unseen forces that run the universe.
That obsession led him, at just 16 years old, to his first great thought experiment. He asked himself this wild question: what would I see if I could actually catch up to a beam of light? If I could race alongside it at its own insane speed? Would the light wave just freeze? Look like a static wave just hanging there in space? The question absolutely consumed him. He said thinking about it made his palms sweat. And this very question set him on the path to his first revolutionary idea.
See, the problem was that the physics he inherited was fundamentally broken. You had Isaac Newton's laws of motion on one hand, a 200-year-old bedrock of science saying all speed is relative. But on the other hand, you had James Clerk Maxwell's brand new, brilliant theory of electromagnetism, which proved the speed of light is absolute. It's always the same no matter what. These two pillars of physics were in a direct fight with each other. And if there's one thing Einstein hated, it was a contradiction. He knew something had to give.
To solve this, he pictured another scene in his mind. Imagine a person standing on a train platform, right in the middle of two spots. At the exact same instant, lightning hits both of those spots, okay? Since he's perfectly in the middle, the light from each bolt travels the same distance and hits his eyes at the exact same time. For him, those two events were, without a doubt, simultaneous.
But now, let's put someone else on a train that's speeding through that station right as the lightning strikes. She's moving toward the lightning strike in front of her and away from the one behind her. So for her, the light from the front strike has less ground to cover to reach her eyes. It gets there first. From her perspective, the two events were absolutely not simultaneous.
So, who's right, the person on the platform or the person on the train? And this is where Einstein's genius just shines. His answer was, they both are. And that seemingly simple answer has a mind-blowing consequence. It means simultaneity is relative. It means the very flow of time itself depends on how you're moving. And with that one thought experiment, poof, the 200-year-old idea of a single universal clock ticking for the entire cosmos was shattered.
He called this theory special relativity, but he knew it was incomplete. I mean, it didn't deal with acceleration, and it completely left out that big mysterious force from his childhood, gravity. Tackling that puzzle would lead him to what he later called the happiest thought of his life.
I mean, think about it. You're on an airplane during takeoff, and you feel that force pushing you back into your seat, right? That feeling of acceleration. It feels a lot like gravity, doesn't it? Einstein started to wonder, is that just a coincidence? Or is it a clue to something way, way deeper?
This led to his next amazing thought experiment. He said, imagine you're in a sealed box, like an elevator, floating in deep space. If a rocket starts pushing that box upwards, you'll feel yourself being pressed to the floor, just like gravity. Now, what if that same box was just sitting on the surface of the Earth? You'd feel the exact same thing. And here's his stunning insight. There is no experiment you could possibly do inside that box to tell the difference. Gravity and acceleration aren't just similar, they are, in a very real sense, the same thing. They're equivalent.
And that was the key that unlocked everything. If gravity is really just acceleration, then it's not some mysterious force reaching out and pulling things. It's a property of the universe itself. He realized that space and time weren't this fixed static stage that things happen on. No, they were woven together into a single, dynamic, flexible fabric. spacetime.
He had the core idea, the foundation for a whole new theory of gravity. But turning that beautiful concept into cold, hard mathematics, well, that was a brutal, decade-long fight. And the final, desperate push came during one of the most intense moments of his entire life.
In November of 1915, he was set to give 4 lectures in Berlin to present this new theory. The only problem? He hadn't finished it yet. Week after week, he's standing up in front of his peers, finding mistakes in his own work, frantically revising his equations, all while knowing a rival was about to publish a similar idea. He was running out of time. Then, he tried his new equations on a problem that Newton's theory could never quite solve, a tiny wobble in Mercury's orbit. And the numbers matched perfectly. He knew he had it.
And so, on November 25, 1915, he presented the final result. A full decade of imagination, struggle, and insight all boiled down into one impossibly beautiful and elegant equation. He called it general relativity.
It's just, look at the elegance of this. It's almost poetic. On the left side, you have pure geometry, the actual shape and curvature of the universe. On the right side, you have all the stuff in the universe, all the matter and energy. And that little equal sign in the middle, that's the bridge. It means that the stuff in the universe tells spacetime how to curve, and in return, the curvature of spacetime tells all that stuff how to move. What we feel as gravity is just us traveling along the curves in the fabric of reality.
It was, without a doubt, one of the greatest intellectual achievements in human history. But back in 1915, it was still just a theory on a piece of paper. The world needed proof, and when that proof came, it would arrive in the most dramatic way possible, and it would turn Einstein from a respected physicist into a global superstar.
His theory made a truly bizarre prediction, that the massive gravity of the sun should actually bend the fabric of spacetime so much that it would change the path of starlight passing by it. So in 1919, an astronomer named Arthur Eddington sailed to an island off the coast of Africa during a total solar eclipse to put it to the test, and what he saw changed the world. The starlight was bent, precisely as Einstein's math said it would be. The newspaper headlines were just incredible. Lights all askew in the heavens. It was true. Reality had been reimagined.
And don't for a second think this is just some abstract cosmic idea. It has stunningly practical consequences for you and me. You know the satellites that run our GPS? Well, they're moving really, really fast, and they're in a weaker gravitational field than we are down here. According to relativity, that means their clocks actually tick just a little bit faster than ours. If we didn't correct for Einstein's theories, your GPS would be off by 6 miles every single day.
You know, from a child's compass to a beam of light to an imaginary elevator floating in space, Einstein proved that the most powerful laboratory for understanding the universe is the human mind. He used the geometry of his own thoughts to figure out the geometry of the entire cosmos. Which just leaves you with one big question, doesn't it? What fundamental piece of our reality is just sitting there, waiting for the right person to ask the right question, to be completely reimagined next?